Hello everyone, welcome back to the channel. So in last video we implemented the insert, we already implemented contains method, and we have done the lookup of the particular word in the try, and we have traversed as well. Now as part of this video we are going to implement the remove method in the try. So let's get into the implementation of remove method. Okay, this is our main remove method. Let me change this to word. Perfect. This method should be public, and now let's make our recursive method, which is remove our root node word and then the index. So the index will start with 0 obviously, so we are passing 0 here directly. Now let's create that method, another private method. This is root, this is word, and this is going to be the index. Okay, let's talk about base condition. If index is equal to word dot length, then we are supposed to exit, but before we exit we will make root dot is end of the word is equal to false, because we want to make sure that word is removed. Okay, now this is the indicator that tells us that that word is there or not in the try, and once we remove this indication we can tell that that word is not there. Okay, our contains method, if you are trying to search for that particular word, it will return false. Okay, so your base condition is in place. Now let's take the character for that particular index. First time it will be word dot caret, which is going to be index value, that is 0. So this is the first character. Now we are going to get root dot get child for that particular character. Let me hold it in a variable. Okay, now if this child is equal to null, right, you no need to go ahead and check for anything else. Okay, there itself you can return the control. Now if this is not null, then you're supposed to go ahead and continue the iteration for the removal. How do you do that? You again call the removal method. Now this is going to be the child node, the word, and you have to do index plus 1, because we know the child exists. We already verified that. Okay, once you're done checking that, you can actually remove it. You have already marked the word as false, but you can actually remove it from the try itself. Now how do you do that? For that you have to check two conditions. Okay, so now you see I'm writing this condition after this removal call, which is actually a recursive call, and I'm writing it after that because once this reaches the end of the word, right, so in a reverse manner from last node we start removal. Okay, so this condition will actually perform removal in a post order manner. Okay, so what will be the condition? If your root dot children, if your root does not have any more children and root dot is end of the word is false, that means this is the last node and there is no other word marking the completion of it. So in that case what you're supposed to do, you're supposed to call root dot remove child. You can pass the character because that's a key, and as you can see we haven't implemented these methods, so let's go ahead and implement them. Okay, so first method is public boolean has children. So we have our children, which is a hash map dot is empty. So if the children, which is a hash map, is not empty, then you can say your particular root, right, it has children, because if this is a hash map implementation, if you're telling from hash map that it is not empty, that means it has children. And for the removal, public void remove child, the character, and now the children and the remove method. Now how do I know I have to pass this character here? Because in hash map we already implemented this add child, right, where we have used the put method where the key value pair, this character was the key, so this character we can use to remove as well, and that's why we are calling in such a way. Okay, so here is your remove method. What we are doing here, we called our remove method. Okay, now we created our recursive method which is taking the root word and the index as 0. Then for the base condition we are making sure if index is equal to word dot length, right, that means you are actually at the last character of the word, then you're marking that end of the word is equal to false, telling the try for every single character for that particular index we are taking its child. If it's null we are returning control there itself. If the children are there then we are performing remove call again, passing the child node, passing the word and incrementing the index so that our recursive call can happen. Then once this is done, right, we also want to remove if last node is not attached to the completion of the word. For that we have written this condition: if root does not have any children and the root dot is end of the word, basically last word, right, last character is also not marking any of the end of the word, that means it is false. So we can go ahead and call the remove child method, and there basically we are just through the hash map implementation we are performing the removal call. So that is the implementation of removal method in a try. Okay, now is the time of truth. What we have done here, so first I'm trying to remove a word which is not even there in a try. Then I'm trying to check for that particular word if it contains in the try or not. Okay, then what I'm trying to do, I'm also checking if another word can is there or not, which is actually there. Then I'm removing that word and checking for its existence again. Let me run this so that I can show you if our implementation is correct or not and how it's working internally. How it's working internally I've already explained. Okay, we are getting false, true, false. So false is for the first one because car, this word is does not exist in our try, that's why we got false. Then we are getting true because can is actually exist in our try, that's why we are getting true. And then we are trying to check for its existence again, and then we are getting false. So that shows we are able to remove the can from the try properly, and our implementation that we have written for the removal method is working perfectly fine. So that's all I wanted to explain as part of this video. We'll be also doing the auto completion program. Till that, see you in the next one.